Okay, moving on to 1.3 and 1.4. So far, we've only studied one method of how to determine the winner of an election, the plurality method. It has some pros and some cons. So some of the good things were that it's really easy. It always satisfies the majority criterion, which means that if someone gets a majority of the votes, they must be the winner. There's no way someone could get a majority and not win. But we said that sometimes it can fail to satisfy the Condorcet criterion, and that was that we can have someone who wins all their head-to-head matchups, yet loses in the plurality method. So that was kind of a drawback. And the results are easily manipulated with insincere voting. So we're going to study two new methods today of determining the winner of an election, and we'll see if they're any better or worse than the one method we have so far. So the first one is called the Borda count method. Each place on a ballot is assigned points. So in an election that has n choices, 1 point, last place gets 1 point, second to last gets 2 points, all the way up to first place gets n points. So we'll do a quick example. So here's a preference schedule for the results of a math club election for president. So the candidates are Alicia, Boris, Carmen, and Dave, A, B, C, and D. That's helpful. All right, so we're going to use the Borda count method to determine the winner. Okay. So every person who put A in first place is giving candidate A how many points? 4. Good. So these 14 people put A in first place, and A gets 4 points for every ballot that has them in first place. So how many points total does A get from these 14 people? Yep, 14 times 4, which is 56. So we'll just put a little note there. It's 56 points. Now these 14 people all had B in second place. And how many points do you get for second place in this election? 3. So there are 14 ballots that have B in second place. Each ballot gives B 3 points. So 14 times 3 is 42. And then 2 points for third place, 28, and 1 point for last place. So D gets 14 points for those 14 ballots. So then we do that for each pile of ballots. Question, yes.
Like where did you get the 4 from? Does that just keep on going up?
It depends on how many candidates there are. There are 4 candidates, so first place gets 4 points.
Okay.
When there are 5 candidates, first place gets 5 points.
Okay.
Sure. So now this pile of 10 ballots all has C in first place, and C gets 4 points for every first place ballot. So this is 40 points to C, 30 points to B, 20 to D, and 10 to A. So it can sometimes be helpful if you label, right, just to remind yourself. And then it's really just multiplication. 8 times 4, 32. 8 times 3, 24. 8 times 2 is 16, and 8 times 1 is 8. And then we have 16, 12, 8, and 4, and 4, 3, 2, and 1. So these are all the points. Now we just have to add up who got the most points. Okay, so candidate A has 56 plus 10 plus 8 plus 4 plus 1. So that's 66, 74, 78, 79 points for candidate A. And candidate B, they have 42 plus 30 plus 16 plus 16 plus 2. So that's 72, 88, 104, 106. And candidate C has 28 plus 40 plus 24 plus 8 plus 4. So that's 68, 78, 88, 92, 100, 104. And then D has 14, 20, 32, 12, and 3, and that adds up to 81. Thanks. Okay, so who wins?
B.
Candidate B got the most points. Winner. So it's not too bad a method in terms of difficulty, right? Who would have won? Well, actually, let's see what comes up next. Who would have won this election if we used the plurality method? A. Yep, the most first place votes would be A. Yep, so A would have 14 first place votes, B would have 4, C would have 11, and D would have 8. So A would be the winner if we used the plurality method. But in the Borda count, B was the winner, right? So we get two different winners, two different methods. Which method do you think is better in this particular case? Who?
I like the Borda.
Yeah, why do you think Borda?
Because obviously A is getting 7 to 9. It's vastly, B is vastly.
Okay, so in Borda, A actually has the fewest points. Yeah, why is that? Why is it that A has so few points when they're the plurality candidate?
Because of the last place choice in every other.
Yeah, because these 14 people have A in first, but everyone else has A in last place. So A is a very polarizing candidate. Some people really like A and some people really don't like A. So candidate B, the Borda count winner, is more of a compromise candidate. We have second choice, third, first, and third choice for different people. So no one has B in last place. Some people like B a lot. So B is a good compromise. So let's see, we said Borda because a lot of people don't like A. So what do you think are some advantages of the Borda count method? What do you like about this method?
It's a lot easier.
Easier than the plurality method? Okay. Well, it's definitely easy. It's not too bad. Yep.
It's really not an all or nothing.
Not all or nothing. I like that.
Seems more fair.
Fairness. Yeah. Fairness and compromise. Yeah, these are all really good things about the Borda count method. So before we try to list some disadvantages, we're going to go through an example that's going to highlight one of the big disadvantages. Okay. So we have the 4 finalists for the job of school principal: Mrs. Amaro, Mr. Burr, Mr. Castro, and Mrs. Dunbar. After interviews, each member of the school board ranks the 4 candidates on a preference ballot, and these are the results. So is there a majority candidate? Is there a candidate who has more than half the first place votes? Yeah. So how many people total voted in this election? 11. Yep, we have 6, 8, 11. Right? 6 plus 2 plus 3 makes 11 voters. So if you have 11 voters, how many votes make up a majority? 6. Yeah. Because you need more than half. So exactly half is 5.5. So 6 votes would be more than half the votes. So yes, candidate A is a majority candidate. Candidate A is a majority candidate. So according to the majority criterion, you know, one of our measures of fairness is that if we have a majority candidate, they should win, regardless of what method we use. Okay, that's sort of one of our ideals of fairness, is that majority should rule. Okay, if the majority has a voice, they should win. All right, is there a Condorcet candidate? Is there a candidate who would beat anyone else head to head? Who? A. A is also Condorcet. So if I did A versus B, A would get 6 votes, B would get 5. They would get these 2 and these 3, because both of those sets rank above A. 6 to 5, A wins. And if I do A against C, it is again 6 to 5. And A against D, it is again 6 to 5. So A wins all of their head-to-head matchups. A is a Condorcet candidate. So A is a really strong candidate. They have a majority of the votes. They're preferred over any other candidate in a head-to-head matchup. Those are the only 2 fairness ideals that we've talked about so far, is majority and Condorcet. And A satisfies both of them. So the question is, what happens if we determine the election with Borda? So I want you, in your groups, to determine who wins this election using plurality. So that is, who gets the most first place votes. And then determine who wins this election using Borda. So Mr. Burr wins, even though candidate A is such a strong candidate, right? Candidate A has a majority of the votes, they're Condorcet, but they lose, right? So what are some disadvantages of Borda count? Yeah. Yeah. It could really hurt you, yeah. So a candidate has to be well liked, even if they're not the favorite. They have to be well liked by everyone, or most voters, right? So that example showed that it's possible that you can have a majority candidate who loses and a Condorcet candidate who loses, which means that this method, while it is good in that it produces a compromise candidate, that forces us to sometimes violate those 2 basic fairness criterion that we talked about. So that's a big drawback, is that sometimes Borda violates the majority criterion and Condorcet criterion.
Is there a instance where all these work together? They all bring the same candidate?
Yes, definitely. There are instances in elections where every method will give the same result and no fairness criterion are violated. But our search is to find a method that never violates a fairness criterion. And if we've created an example where it does, you just never know when it's going to happen, right? Now we know that it can. Yeah, all these fairness things go away, right? Because if you only have 2 candidates, someone will always have a majority. Someone will always win all their head-to-head matchups because there's only one head-to-head matchup. Yeah, and with Borda, one would be in first place, and everyone has to vote one way or the other. Yeah. So we know the plurality method is used the most often, but Borda is very popular. It's used for a lot of sports awards, like I think the Heisman Trophy I want to say like the NBA Rookie of the Year. A lot of music awards use a board account system to determine the winner. When a board of directors for a company or an organization has to vote, they often use board account. So this is actually a quite popular method, just not as visible as the plurality method. Okay, so we're going to learn one more method today. Third total. It is called plurality with elimination. It's also known as instant runoff voting. So if you ever see that in the news, this is what they're talking about. Or the Hare method, it's also called. So in this method, you eliminate the candidates that has the candidate that has the fewest first place votes until someone has a majority of the votes. So you just keep eliminating candidates, redistributing their votes, and once someone gets a majority, you're done. So these are the rules. Count the first place votes for each candidate. If someone has a majority, then he or she is the winner and you're done. Okay. Otherwise, you eliminate the candidate with the fewest first place votes. They're out. You take their votes. Step 2 is you take their votes and redistribute them to the remaining candidates. No, according to the preference ballot.
Oh, okay.
Yep, according to the preference ballot. Then recount. If someone has a majority, they're the winner, you're done. And if no one has a majority, eliminate the candidate with the fewest first place votes and do it again. Repeat until someone has a majority. We have an example, yeah. It'll be clearer once we do one, yeah. Okay, so we're gonna use the same math club election that we looked at before. And let's just remind ourselves, A, one with plurality, and B, one with Borda. So let's see what happens when we do plurality with elimination. So round 1, count up the first place votes for each candidate and see if someone has a majority. So candidate A has 14 first place votes. Candidate B has 4. C has 11. And D has 8. So how many people voted all together in this election? 41? Yeah, 18, 29, 29 plus 8 is 37. So we have 37 voters. So how many votes would it take to get a majority? 19. You just need more than half the votes. Exactly half would be 18 and a half, right? But you can't get 18 and a half, first of all. And second, you have to have more than half to get a majority. So 19 votes for majority. Does anyone have a majority? No. So we eliminate the candidate that has the fewest first place votes. Who would that be? B. B is going to be gone. So B's 4 first place votes, their votes are going to go to D. Exactly. B is now gone. And we can tell from these ballots that these 4 people who wanted B as their winner, if they can't have B, they would take D as their second choice. So we're going to distribute those 4 votes to D. So D now has 12 votes. Sure.
That doesn't happen with all the, like, every letter below B. Like,
Right.
just the first
You
place.
just give it to the first place. Yep. Yep. Okay, so then we recount the first place votes. So we now have A 14, B is gone, C has 11, and D has 12. Okay, does anyone have a majority? Nope, so we have to do it again. Who do we eliminate? C. We have to go up to the preference schedule and decide who gets C's votes. So these 10 people would have chosen B, but B is gone, right? So those 10 are going to go to D. So we give 10 more votes to D. And then this one person, their vote is also going to go to D, right? So all of C's votes go to D. So we have 23 votes for D. D has a majority, so D wins. How do we feel about this? Question?
So as soon as one of them passes the majority, you just stop everything you're doing.
Yep, and declare them the winner. So D1, right? Same election, we've had 3 different methods, and now we have 3 different winners. A with plurality, B with Borda, and D with plurality with elimination. Okay, so here's a practice. I want you to use the plurality with elimination method to determine the winner here. All right, so I saw a lot of people come up with E as the winner with 153 votes. Okay. So if you did not come up with E or 153 votes, then you've made a little mistake somewhere. Check with your group, or you can ask me after class and we'll go over it then.
I like this one.
Yeah. Okay, and then what about this one?
Okay.
A. We don't have to do any work at all. Oh, whoops, I forgot to turn the recorder back on. Oh no, it's on. I don't have to do any work at all because I already have a majority, right? A has a majority. So I don't have to do any elimination. A is the winner. Okay, so what are some advantages? What do you like about this? Okay, easy.
It's harder than the board account for me.
Okay. Though maybe not the easiest of all our methods. It's still relatively easy to explain to someone how it works. Yeah. And that's an important fact. I mean, we really want voting methods that aren't so complicated that the general public can't understand, because then people are going to be like, it's just magic. Why do I even vote, right? Okay, so what else is good about this?
It seems more fair in a sense, because the people that are lower ranks, like 3rd and 4th, points are distributed to them. So
It tries to satisfy the lowest.
right.
Okay, so it takes the full preference of a voter into account.
Right.
Which so did Borda, but this one can't violate the majority criterion, because if someone has a majority, they win, right? So that's it does. So that's a good thing about both Borda and this one, but then this one can't violate majority.
So the higher ups can actually pick how they want the voting to go. Like, will they go through all of them and see a better shot, or they decide that, oh yes, we're going to use the polarity with elimination method?
No, usually voting methods have to be set before the election.
Okay.
Yeah, otherwise people will can easily claim corruption. You know, oh, you just used the method that gave you the result you want, right? Yes. Usually, like what's it called? Yeah, you vote on it, but there's you know, like a constitution, or like there's something that your organization has that spells out how everything's going to run. Exactly. You don't know which one's going to benefit you ahead of time. Yeah. So you generally have to decide which one you think is fairest and go with that forevermore. Okay. It's hard to rig if you choose before. Yeah. Right. Exactly. Okay, so we have several advantages. Again, before we list some disadvantages, we're going to look at one more example. So we have 3 cities, Athens, Barcelona, Calgary, competing to host the Summer Olympic Games. The final choice is made by a vote of the International Olympic Committee, and the winner is chosen using plurality with elimination. And this is real. This is the voting method that they use. So 2 days before the actual election is held, they take a straw poll just to see how things stand, see who's in the lead, that kind of thing. Okay, so these are the results. I want you to figure out, based on these results, who's expected to win. Use plurality with elimination. C turns out to be the winner with 18 votes. All right, so Calgary's in the lead, right? The results were supposed to be a secret, but the results leak out. And since everybody loves a winner, the 4 delegates in this 4th column who voted A, C, B, they say, you know, Calgary's going to win. We want to be on that bandwagon. We're going to switch it, so we vote now C, A, B. They're going to put Calgary as their first choice instead of Athens. I want you to draw a new preference schedule, make a new little table with the new voting, okay, and determine who wins. So really all you got to do is that and determine the winner now. Just do it over again and determine the winner. So now Barcelona is going to be the host of the Olympics instead of Calgary. What? Isn't that weird? Like, the only change was something positive for Calgary, right? Calgary was going to win. They were in the lead, all set to win. And the only thing that we changed is we gave Calgary a boost in one of these columns. We tried to help, right? We tried to help Calgary. Even though they were already going to win, we just gave them a little extra boost, and then they lost. Right. So Calgary becomes a quirk of the plurality with elimination method. This is actually an example of a violation of something called the monotonicity criterion. Okay, so this one says that if candidate X is a winner in an election, and we have a re-election for whatever reason, maybe the first election was a straw poll, maybe there were irregularities and they had to call everyone back to the polls and hold a re-election. Candidate X is the winner of the first election, and in a re-election, the only changes in the ballots are changes that favor X, where people move X up on their ballot. Then X should remain the winner. Okay? In order to deem the election fair, if X won the first time and the only things that changed were good things for X, we would expect X to remain the winner. Okay? If that doesn't happen, we say we violated the monotonicity criterion. So that's the big disadvantage of plurality with elimination. Can sometimes violate the monotonicity criterion. Yeah. In order to win again, yeah.
First time, he doesn't have authority at the beginning, he's going to lose.
Yep. And also, I didn't show you an example, but it also sometimes violates Condorcet. So it's possible for someone to win all their head-to-head matchups and not win in the plurality with elimination method. So plurality with elimination is used quite a lot also. It's used by the International Olympic Committee, San Francisco and Burlington, Vermont, municipal elections, and Australia's elections for members of their House of Representatives. All right, so your homework for class 2, it's page 32, 17 to 33 odd. And I finished way fast.